So the first topic that we are going to explain is about compound interest. Compound interest is interest calculated on both the initial principal and all of the previously accumulated interest, generating interest on interest, and it can be compounded on a variety of frequencies such as daily, monthly, quarterly, and annually.
Next problem statement. Mr. Gary made an investment of 25,000 ringgit from Maybank for 5 years at an interest rate of 2.15% compounded semi-annually. Okay, for question A, we are asked to find the accumulated amount, which is the S, using compound interest formula, S equal to P1 plus I to the power of N. So now we substitute the values into the formula, and it will be S equal to 25,001 plus 0.01075 to the power of 10. And we got the answer S equal to RM27,821 ringgit and 31 cents.
So question B is find the interest earned by Mr. Gary after 5 years. So the formula that we use to find interest is I equals to S minus P. So S is 27,821 ringgit 31 cents minus 25,000 ringgit. So we get I equals to RM 2,821 ringgit 31 cents.
So question C, after 2 years, Mr. Gary invests another 5,000 ringgit. Find the accumulated amount of his investment after 5 years. So this question involves compound interest with 2 time periods, but the interest rate stays the same for both periods. So we must calculate the future value in 2 stages. Okay, now for the first stage, given principal 25,000, interest rate is 0.01075, and number of years is 4. So using the compound interest formula, S equal to P1 plus I to the power of N. Now we substitute the values into the formula. So S equal to 25,001 plus 0.01075 to the power of 4. We got the S, 26,092 ringgit and 46 cents. Okay, now this value becomes the new principal, which is P2 for the second period. So P2 equals to 26,092 ringgit and 46 cents plus 5,000. So it will be P2 equals to 31,092 ringgit and 46 cents. So we add RM 5,000 because a new investment was made at this point. Okay, now we move to the next stage, which is the second period. So the rate still remain as 0.01075, but use the new principal, which is the P2. So P2 equals to 31,092 ringgit and 46 cents. And now we use the new number of years, which is 6. So now we substitute the values into the same formula using the new principles. S equal to P2 1 plus I to the power of N. So now S equal to 31,092 ringgit and 46 cents 1 plus 0.01075 to the power of N. The final amount will be 33,152 ringgit and 60 cents.
Question D. Calculate the amount at the end of the investment if Maybank changed their investment rate on 30 years at 2.10%. So first step is using the formula of S equals to P open bracket 1 plus I close bracket to the power of N. So with the info, P is 25,000 ringgit open bracket 1 plus I is 0.021 divided 2 close bracket to the power of N is 4. So we get S1 or P2 equals to RM 26,066 ringgit 65 cents. So the next step is we using the formula of S2 equals to P2 open bracket 1 plus I close bracket to the power of N. So P2 that we get the answer from the step 1, which is 26,066 ringgit 65 cents open bracket 1 plus I is 0.021 divided 2 close bracket to the power of N is 6. So the final answer is S2 equals to RM 27,752 ringgit 56 cents.
I will explain about annuity. So annuity is a sequence of equal payment made at regular time intervals that are computed using the compound interest method. This is a problem statement for annuity. Jamila wants to make a loan with Maybank to get married. She borrowed 20,000 ringgit for 5 years loan by making equal monthly payment to the bank. The first payment installment is due 1 month after the date of loan and the interest rate is 7% per annum compounded annually. So for question A, we are asked to determine the amount of monthly payment that Jamilah must pay. So we're going to use annuity formula, which is S equals to R, open bracket 1 plus I, close bracket to the power of N, minus 1 over I, close bracket. So we're going to substitute the values to the formula. So 20,000 ringgit equals to R, open bracket 1 plus 0.07, close bracket to the power of 5 minus 1 over 0.07, close bracket. So 20,000 equals to R, open bracket 4.1002, close bracket. So R equals to RM 4,877.81 cents. So for question B, we are asked to calculate the total interest secured by Jamilah. So we're going to use this formula, which is I equals to R times N minus A. So I equals to RM 4,877.81 times 5 minus RM 20,000. I equals to RM 24,389.05 minus RM 20,000. So I equals to RM 4,389.05.
Question C. Determine the outstanding amount that must be settled in the 6th month if Jamilah missed her first 5 monthly payments. To solve this, we use the Taylor value of an annuity formula. In this question, A is the loan amount, which is RM 20,000. R is the monthly payment we want to find. I is the interest rate per month. N is the total number of payments remaining. First, we calculate the annuity pattern. At the interest rate, 1 plus 0.07 equal to 1.07. Rate e to the power of negative 26. Subtract this from 1. Divide by the interest rate 0.07. This value, 11.8258, is the annuity factor. Next, we substitute into the formula. 20,000 equal to R 11.8258. This means the outstanding amount per payment is RM 1,691.22, which must be paid starting from the 6th month. Question D. Determine the monthly payment for Jamilah loan using the annuity formula. First, we use the formula for the future value and annuity. In this formula, S is the total loan amount, R is the monthly payment we want to find, I is the interest rate per payment, N is the total number of payments. On the question, the loan amount is RM 1,621.22. The interest rate is 7% and the number of payments is 8. So we substitute these values into the formula. We start by calculating the annuity factors. At the interest rate, 1 plus 0.07 equal to 1.07, raised e to the power of 6. Subtract 1. 1.50073 minus 1 equal to 0.50073. Divide by the interest rate. This value, 7.1533, is called the annuity factor. Next, we rearrange the formula to find the monthly payment R. So, R equal to 1,691.22. 7.1533 equal to RM 20,097.13. Therefore, Jamilah must pay RM 2,097.80 each month.